Hello everyone, myself Harshini and I'm from Sri Venkateshwara College of Engineering. Today I'm going to discuss about the storage classes in C program. Let us know the storage classes of a C program. Introduction to storage classes. Storage classes determine the lifetime and visibility of a variables in programming languages. They are essential for managing memory efficiently during the program executions. Understanding the storage classes is crucial for optimizing resource usage in a software development. Let us know the importance of a storage classes. Storage classes play a significant role in a variable scope and lifetime. They help in managing the memory allocations and delocations efficiently. Familiarity with the storage classes aids in a preventing a memory leaks and undefined behavior. Let us know the types of a storage classes. What are the types of a storage classes? There are four primary types of storages classes in a C and C++. These include automatic, static, external and register storage classes. Each type has a unique characteristics in a terms of a visibility and lifetime. Let us know the one by one. Automatic storage classes. Automatic storage classes is the default storage classes for local variables. Variables declared within a function or a block are automatically allocated and delocated. The scope of an automatic variable is limited to the block in which they are defined. And then we know the characteristic of the automatic storage classes. Automatic variables are created when the blocks is entered and destroyed upon exit. They are stored in the stock memory which allows for a quick access. Automatic variables are not initialized by the default, potentially leading to the garbage values. Now let us come to the static storage classes. Static storage classes maintains the variables values between the function calls. Variables declared with the static keyboard have a lifetime equal to the program's executions. Their scopes is a limited to the block where they are defined, but they retain their value. And the characteristics of the static storage classes or the static variables are initialized only once at the starting of the program executions. They are stored in the data segment of the memory, not on the stack. Static storage classes is useful for preserving a state information across the function calls. And the external storage classes. The external storage classes allows the variables to be accessible across multiple files. Variable declared outside of any function are considered to have an external linkage. They exist for the lifetime of the program and they retain their value throughout. The characteristics of the external storage classes. The external storage variables are initialized to 0 by default if not explicitly initialized. They can lead to potential naming conflicts if not managed correctly. External variables are stored in the data segment similar to the static variables. They are similar to the static variables and the register storage classes. These register storage classes suggest that the compiler store the variable in a CPU register. This can enhance the performance by allowing a faster access to frequently used variables. However, the number of registers is limited, so not all variables can be stored this way. The characteristics of a register storage classes. Register variables cannot be accessed via pointers as they may not have a memory address. The lifetime is the same as automatic variables but they are stored differently. The use of a register storage classes should be judicious to avoid a resource constraints. Comparison of a storage classes. What are the comparisons of a storage classes? Storage classes can be compared based on the scope, lifetime, and storage locations. Automatic and register classes are in a local in a scope, while static and external are not. Understanding these differences helps in selecting the appropriate classes for our variables. Scope of a storage classes. What are the scope of a storage classes? The scope of the variable determines where it is can be accessed in the program. Local variables are only accessible within their defined blocks. Global variables can be accessed from any part of the program, enhancing the flexibility. Now, let us know the lifetime of a storage classes. The lifetime of a variable refers to the duration it remains in a memory. Automatic variables exist only during a function execution, while static and external variables persist. Proper management of a variable lifetime is essential for resource optimization. Memory allocation in a storage classes. Memory allocation refers to how and where variables are stored in a memory. Automatic variables are allocated on the stack, while static and external variables are on the heap. Register variables are allocated in a CPU registers, offering the fastest access times. Best practices for using a storage classes. The best practices for using the storage classes are the choosing the appropriate storage classes based on a variable usage and the requirements. Minimize the use of a global variables to avoid naming conflicts and unexpected behaviors. Always initialize a variables to prevent errors due to garbage values. Common mistake we made in with the storage classes or failing to understanding the variable scope can lead to the unintended access and modifications. Overusing global variables can create dependencies that complicate the program maintenance. Neglecting to initialize the variables can cause a unpredictable behavior during the executions. Let us come to the conclusion. Understanding the storage classes is visual for effective memory management in programming. Properly utilizing the storage classes can enhance the performance and reduce the errors. This continuous learning and practice can help developers master storage classes concepts. Thank you.